Okay, we're continuing, we're going on to lesson 26. And here we have section 5.3, Trigonometric Functions, Part 1. So lesson 26, the assignments for that are actually split up into two parts, two lessons. Okay, we looked at the right triangle, and here we have the right triangle on the coordinate plane, where we have our x values and our y values. So, and we have this point here, and so we have x and y. So the first, part, that's always your x coordinate, as always. That hasn't changed. And which trigonometric function is synonymous with x? Sine, cosine, tangent, secant, cosecant. Well, careful. Well, sine is, it's cosine, right? Cosine is synonymous with x. Sine is synonymous with y. Okay, so sine, if we're looking at our SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Our reciprocals, since sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite, and so on. Secant, hypotenuse over adjacent, and cotangent adjacent over opposite. Okay, that hasn't changed. Okay, that's just another diagram of what we've already looked at. All right, so here we have a triangle, and we have three values, 25, 7, and 24. We want to find sine, cosine, and tangent values for angles A and B. Let's look at angle A. What would be the values? What would be the value for sine of angle A? Sydney? Remember now, sine is what? Opposite over hypotenuse, right. So what would be the side opposite of angle A? 7, good. And then the hypotenuse? 25, right. So that would be 7 over 25, good. And how about cosine? Travis? Good, 24 over 25. And Harley, how about tangent? Remember now, tangent is what? Opposite over adjacent. So what would tangent values for tangent be? 7 over 24. Good. Okay, now for B, that's a little bit trickier because normally you're used to seeing it off to the side here like this. But B, opposite is the 24. Adjacent is the side next to the B. That's 7. So sine is opposite over hypotenuse. Okay, the hypotenuse is always going to be opposite the right angle no matter where A and B are. Okay, so that makes it 24 over 25. How about cosine for angle B? What would that be? Yeah, because that's adjacent, right? 7 is adjacent over 25. Good. And how about tangent? 24 over 7. Very good. All right, questions with that so far? Okay. So for sine, theta, 30 degrees, is 1/2. Now these are special angles here, 30, 45, and 60. cosine is square root of 3 over 2, tangent square root of 3 over 3, and then the reciprocals, cotangent, that would be 3 over square root of 3, and so you'd rationalize it and you just get 3. Secant, you just flip, applying the reciprocal, the cosine, and you get 2 square root of 3 over square root of 2 over the square root of 3, so you rationalize that and you get 2 square root of 3 over 3. And then cosecant, you just flip the 1/2 and you get 2 over 1, or just 2. Okay, 45, square root of 2, and square root of 2 for 2 over 2, and square root of 2 over 2 for both cosine and sine. Tangent is 1, cotangent is 1, secant and cosecant. And then for 60, square root of 3 over 2, 1/2, and square root of 3. Well, there's an easier way to remember than to look at this table. Now let's see how we can do that. It's not enough room here, so I'll have to let's redo this. Maybe it's 60, 30. Yeah, okay, so this would be, yeah, okay, here it is. All right, you've got 30 sine for 30 degrees is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is going to be opposite over adjacent, which you have to rationalize that. So you get square root of 3 over 3. And then for 60 degrees, it's going to be sine for 60 degrees is opposite over hypotenuse. So that's square root of 3 over 2. Cosine of 60 degrees, that'll be 1/2. And tangent is going to be square root of 3 over 1, or just square root of 3. All right, so you start off with 60, 30, and you radic your right angle and go 1, 2, square root 3 like that. Okay. Given a triangle ABC with sides A, 7, B, 12, use the Pythagorean Theorem to find the remaining side and then find the values of the 6 trigonometric functions. Okay, now here they don't give you a picture. So we have to go ahead and draw one. We're given side A is 7 and B is 12. All right, so we want to draw a triangle. The angles use the uppercase letters, A, B, and C. The lowercase are the sides opposite that angle, so this would be side A is opposite angle A. Side B is opposite side angle B, and side C is opposite angle C. So from here, we need to find, we said that A is 7, B is 12. All right, and so we need to find side C. Okay, so we're going to use the Pythagorean Theorem here. C squared equals to A squared plus B squared. Okay, so this will be C squared equals to 7 squared plus 12 squared. And so that'll be 49 plus 144. And we get 193. Okay, so we apply the square root to that. Okay, and for triangles, it's always just a positive square root. So for 193, you want to see if anything can simplify into that, such as 3 or, well, 5 won't. And so it looks like we're just going to have the square root of 193. So from there, we go ahead and find the other 6 trigonometric functions. And we'll use angle A in reference to angle A. So this would be sine for angle A, sine, cosine, tangent, and then cosecant, secant, and cotangent. All right, so go ahead and find the rest of those. Values. Okay. Dylan, what would you get for sine A? Okay. 7, because it's opposite over hypotenuse, right? 7 square root 193 over 193. All right, good. And so cosecant would be what? Basically, if we started with 7 over square root of 193, right? Then that means cosecant would have to be what, Harley?
Square root of 193 over 7.
Right. Square root of 193 over 7. Okay. Sydney, how about cosine?
12 square root 193 over 193.
12 square root 193 over 193. All right. And so secant. Right. Square root of 193 over 12. And tangent? Travis?
7 over 12.
Okay, good. 7 over 12. And so cotangent would be
12 over 7.
12 over 7. Good. Now, if you wanted to find B, right, sine would be, what's the side opposite of angle B? Sydney? 12, right. And then 190 over 193. Okay? Okay. Any questions with that? All right, so if you had a triangle that looked like this, and we had Y, K, and Z. And we have angle A here. and B and C. Okay, find the 6 trigonometric values for sine angle B, cosine, and tangent. Okay, go ahead and find those values. We don't have numbers, we just have z, y, and k. All right, so you're just trying to find the ratio, right, based on the SOHCAHTOA. Well, first of all, here's angle B, right? What's the side opposite angle B? Is it Y, Z, or K? Sydney? Y. It's Y, right. And what's the hypotenuse? Z. Z, good. All right, go ahead and finish that. Okay, Dylan, sine. Okay, y over z, opposite over hypotenuse. Good. And cosine? Good. K over z. Adjacent. Adjacent over hypotenuse. Good. And Harley, how about tangent B? Well, careful now, it's tangent is opposite over adjacent, right? Y over K, right. Okay, good. Questions with that?